Okie dokie. So, here's our third free response question for this week, dealing with masses and springs. And here we have it's kind of like a pogo stick. It looks like a kid, well, they're describing it as a kid's toy that goes boing, 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 boing. So, this thing is initially at some equilibrium position. You compress it, and there's mass here, right? The spring and the base are negligible mass. You compress it and then let it go, and it's going to shoot up into the air. So what we're looking for is how high does it go, and that's going to be a function of how springy the spring is, the mass, the acceleration due to gravity, and how much you push it. So this, part A, I know that this can be intimidating when the question says derive an expression for the height h in terms of m, x, k, and fundamental constants. They don't even tell you what fundamental constants, they don't give you any numbers. It's easy to freak out and say, I have no idea. But you do know the concepts involved, and it turns out this is an example of a question that's actually really simple when we take a look at the solution. So what happens is, here's the concepts involved. We compress this, so we have this elastic potential energy, or this spring potential energy. And that's going to spring, right, and turn into kinetic energy for the mass part. And that kinetic energy, as it moves up into the air, is turned into gravitational potential energy. So when we write this out, it looks like this. So what did I say? I said it goes spring, so this is spring potential energy, to kinetic energy, to gravitational potential energy. So I just said spring potential energy equals gravitational potential energy, divided both sides by mg, and boom, there it is. So that's the correct answer. The actual solving involved was pretty straightforward, but knowing this concept and then knowing, hey, this is this and this is this, and I'm going to set them equal to each other, that's the difficult part. So anyway, here's an expression for the height it goes in terms of the spring constant, the amount you compress it, and then the fundamental constant would be the acceleration due to gravity. Oh yeah, and the mass is in there. Okay. That was fun. B, so let's see, what else do they tell us? Yeah. With the spring compress the distance, so we're completing some different trials, and we're going to push it down by 2 centimeters and let it go and see how high it goes. And we're doing that with different masses. And I think this is to determine the spring constant. So these are the data, alright, and again, it's for this much compression each time. Notice how the more mass there is, the less high it goes. That makes sense. Part B, what quantities should be graphed so that the slope of a best fit straight line through the graph can be used to calculate the spring constant K? So what are we going to graph? If we look at our equation, so we're looking at this guy right here, so this is similar to y equals mx plus b, y equals mx plus b. There's no y-intercept, so we're just going to make that go away. So the number times the variable, this is our slope, and we want to use the slope of the line to figure out k. So if you look at that data, the variables were height and mass. We changed the mass and the height changed, or the students did. The more mass, the less height there was. But we don't, if we graph y equals m over x, that's something totally different, and it looks like that. I'm going to erase this so it doesn't get all crazy. So what we want, and this happens all the time in physics and science, but it might be new to you, is for our variable, we're going to graph 1 over m. So we could rewrite this equation as h equals kx squared over 2g, I might have already put this in the solution, times 1 over, that's not an x, that's an m, 1 over m, and then if we graph this on the x-axis and this on the y-axis, this is our slope from which we can find k. So let's see what I said. Yeah, something like that. So if x is constant, amount of compression, h and m are our variables, so we can graph the height and 1 over m, and we should get some straight line where our slope is this, which is, it's not k, but it's related to k, so we're just going to multiply or divide by something to get k. So we are supposed to fill in the table, so the table would look something like this. If we graphed 1 over m, so I got lazy and didn't write those values in. You, of course, did not get lazy and you wrote them all in. But here's our height, here's our 1 over mass, and we're going to graph it. So, what's our question say? Alright, so you put those values here or here, wherever. The quantities it should be graphed, so height and 1 over mass. And we're going to fill in both the blank columns, which we just did, and then we're going to graph it. So you've got this nice graph paper, maybe even a ruler or something. 1 over m and h here, so see if you can set up the axes and whatever. Again, the more you try this instead of just copying what I say, the more you're going to learn, and that's, yeah, the more you're going to learn. But here's the answer. So let's see, 1 over m, and we went up to 50, so I just sort of sketched out equal partitions, and the height went to 0.5, so some equal partitions, and my points were, I was just kind of eyeballing this, you know, no graph paper, no ruler. This I used the side of a sheet of paper to get the best fit line, but that's pretty good. I mean, the points are pretty close to a straight line, so it's a good sign. Using your best fit line, calculate the numerical value for the spring constant. Whoa. So we're going to find the slope of that line, and then we're going to say the slope equals this. We know the compression was 0.02, the acceleration due to gravity is 9.8. So whatever we get for slope, we're going to set that equal to this and solve for k. So you should try this. Again, I do all this, so you should try it too. I chose, for 2 points on the line, I chose this point way out here and then this point way down here. Notice how there's some uncertainty in my determining what the coordinates of the point are. So the farther away the points are, the less uncertainty or the less inaccuracy I have. I'm going to give you an example if that makes sense, or to help that make sense, sorry. So let's say I'm off by 1, okay? Distance between 3 and 4. If I'm off by 1 here and I'm off by 1 here, I could get anything from 0 to 2, right? Actually, I could get anything from -1 to 3, right? That's a huge range as far as the distance between these 2 points. If I'm talking about, and if I'm off by 1 here, right, I could have 0 and 51, so I could go from 51 down to 40, if this were 2 and this were 49, down to 47, something like that. So those two differences aren't that great. Maybe, hopefully that helped. Anyway, moral of the story, if you're picking 2 points on a best fit line to find the slope, pick the points far apart. Do not pick 2 points like this. Alright, so I did that, and then I'm just using my slope formula. So that is this right here, and I come up with some slope, and this makes no sense to me. It's just some weird number. But if we take a look at the stuff over here, so this was our original equation, sort of the y equals m, and then the x was the 1 over m. Oh, here we go. This looks good. Alright, so these are just numbers. I plugged them in. I know that the slope, so slope, and I know we have an m here, and you're thinking m, slope. No, this was our x variable, this 1 over m. Slope, alright, and then I set them equal to one another, so this equal to this, and then lo and behold, alright, so I got 510 newtons per meter, and that was just, you know, unlined paper, drawing by hand using the side of a sheet of paper for my best fit line, and in the AP we got solutions along with these previously released questions, and what they said was that if the student got anything between 450 and 550, they got credit for a correct answer. So I thought, hey, that's pretty good. Unlined paper, just sketching it, came up with this. So with graph paper and ruler, you should be set. Thanks for listening.